Good morning everyone. Now we are discussing about C tokens. C tokens. Tokens are the building blocks of C programming language. Every program must contain tokens. So the tokens are the compiler which will be compiled. The compiler compiles the program based upon the tokens only. We have 6 types of tokens in C programming language. They are keywords, identifiers, constants, strings, special symbols and operators. Now let us discuss one by one. The first one, keywords. So keywords, there are 32 keywords in C programming language. The keywords have predefined meaning. For example, for is a keyword, means we have loop, right? Different types of loops are there, right? In that, for is one type of loop. If, else, continue, long, float, double. So these are the different keywords which have different meanings, predefined meanings. So like that we have 32 keywords in C language. So the next one is identifiers. So we identify persons with their names, right? So in the same way, in programming language or in the computer terminology, everything we will store in memory addresses, and we can't remember the memory addresses names, memory addresses locations, right? For that purpose we assign names to those memory addresses. Those are called identifiers or variables. So variable or identifier means a stored location which can store data, a stored location which can hold data. So there are some rules how the identifier can be. The identifier can start with alphabet or underscore. So it cannot be start with digit. Doesn't contain special symbols. So the only allowed special symbol is underscore. It should not contain any other special symbols. It can be a combination of digit and alphabet. Means it can be alphanumeric. Keywords are not allowed as identifiers. We have 32 keywords, right? Those cannot be allowed as identifier names because they have already predefined meaning, so that we cannot use keywords as identifier or variable name. So let us explain this with some examples. The first one, ABC. It is a identifier because it is starting with alphabet. 12A, it is starting with digit, so it cannot be an identifier. Next, A12, it is starting with alphabet, it can be identifier. Next, underscore B, it can be start with the variable, can start with the identifier, or variable can start with alphabet or underscore, right? It is a identifier. So next, int is a keyword, right? It cannot be a identifier. Underscore int, so it is not the keyword. So because it is starting with starting with underscore, and it is not a keyword. Next, a at the rate of b, at the rate is a special symbol, so it cannot be an identifier. Next, a underscore b, it can be identifier because underscore is allowed. So these are the different rules for naming a variable or identifier. So next we have constants. Constants means like values, 15, 15.5, 20, like that. Strings. String means it is a collection of characters, combination of characters which can be enclosed in double quotations. See, cyber, America. Your name is also a string. Next, special symbols, underscore, at the rate, and flower brasses. Everything is comes under special symbols. Operators, we have different types of operators like plus, minus, modulo, division. Everything will comes under operator. So with all these tokens, with all these 6 tokens, we will write the program, we will construct the program. Like for example, to construct a house we need cement, bricks, everything, right? So in the same way, to construct a C program we should use these tokens, 6 tokens. So let us explain this in detail with the example program. See here, let's discuss what are the different types of tokens in this program. there. So first void. Void is a keyword, right? And main is a function, right? Function name. Function name means identifier. So main is a identifier. Flower brace, open flower brace. So it comes under special symbol. Int is a keyword, we know that. A, B, C, these are the variable names that are identifier names, identifiers. A identifier, equals to comes under operator. 2 comes under constant. Next, semicolon is also comes under special symbols. Next, B is a variable name or identifier name, equals to operator. 3 is a constant. C, A, B are all the identifiers, equals to plus are all the operators. And printf is a function name, right? So function name of the function, identifier. And braces comes under special symbols. Quotations and the text, it is called string. And C is the identifier. So every word, every letter in this program what we write is one token. So the next topic is variables and data types. Variable, already as we discussed that identifier, same variable is nothing but identifier. It is a stored location where we will store the data, where it will hold the data. Data types. See, let us understand this data types with one example, real-time example. See, here 3 types of garbage is there. So we don't know where which one to be kept in which dustbin, which garbage bin. So because the garbage bins are not labeled. In this example, see, paper. So we will throw paper into this. Glass, cans, plastic, we will throw this. And compost, we will throw this. See, like that, which type of data which type of garbage this garbage bin will hold is clearly mentioned. In the same way, let us connect this with our example. See, for example, data 1, that is 4, data 2, A, data 3, this one. So we don't know in which variable this should be stored. So for that purpose we have data types. So for storing 4, the data type will be integer. For storing A, the data type will be character. For storing 4.7, the data type will be float. So a data type is the type of value that the variable can store. So we know that variable, what is variable, and in that variable which type of data we are going to store is called data type. So, and what type of mathematical logical operations are performed on that data type, it is called data type. So in C, data types are divided into 3 types: primitive data types, derived data types, user defined data types. Under primitive, we already know from first year, we have primitive data types: integer, character, float, double, void. In char, float, void. Next, under derived data types, we have signed and unsigned. Signed means it can have both positive and negative values. Signed, it will mention as minus or plus. Unsigned, we don't have minus, negative values. So unsigned means 0 to positive values. So signed means it can contain both the positive and negative. Unsigned means only positive values. So these primitive data types are divided into signed and unsigned. See, signed char, unsigned char, signed int, unsigned int, signed long, unsigned long. That's like that. And user defined data types. So these are the data types that the user can define. Based upon the primitive data types, the user can define their own data types. Those are called arrays. structures, unions, enumerators. So these data types have sizes. So size, first the character one size, 1 byte. So this size is in bytes. So character 1 byte, short int 2 bytes, int 2 bytes in 32-bit compiler. Now we are using 64-bit compiler, that's why int is also 4 bytes, long int 4 bytes, float 4 bytes, double 8 bytes, long double 10 bytes, void it doesn't have size, enumerator 2 bytes. So here we should remember the main data type sizes are int, float, cat. Integer 4 bytes, float 4 bytes, character 1 byte, 441. See here, 1 byte equals to 8 bits. So here short int 16 bits. Likewise, this will be divided. So here to store integer values, we use int data type. To store decimal values like 3.14 or 5.5, 6.5, we use float data type, float a comma b. And to store character value, we use char data type, char float int. Int is used for to store like integer 2, 3, 4, 5. Float is used for float point numbers, decimal points, character a, b, a. So to store characters, we use char data type. So we have discussed about signed and unsigned, right? So very important topic. At least 2 bits will be asked in your competitive exams. So signed, the range of signed data type is minus 2 power n minus 1 to 2 power n minus 1 minus 1. So why in positive values minus 1 is there means generally positive values will start from 1, 2, 3, right? But 0 is also included in this. So for that 0 in positive range we will have minus 1. So what is this n? N means number of bits. For example, let's discuss about signed char. Char means 1 byte size. 1 byte means 8 bits. So signed char minus 2 power n minus 1. N means 8 here. 2 power 8 minus 1 minus 1. Why minus 1 is included in the exponents? Because signed means it contains both positive and negative values, right? Half will be divided into negative and half will be divided into positive. So n will be divided into n minus 1 here, n minus 1 here. Okay, so that's why in the exponent we have minus 1. So minus 2 power 7 to plus 2 power 7 minus 1. So 2 power 7 value is 128 to 128 minus 1 minus 128 to plus 127 is the range of signed char. The same way unsigned, the formula is 0. It contains only positive values, right? 2 power n minus 1. Why there is no minus 1 in the exponent means all the values will be included only positive values. So see 128, 128, both the values will be included in positives only, that's why. So 0 to 2 power 8 minus 1. This is the range. So 0 to, what is 2 power 8? 0 to 256 minus 1, 0 to 255. So this is the unsigned character. So for example, if a bit is asked like this, if we want to store 256 in unsigned char, so what is the size means? So the range, the size of the range is 0 to 255. So 256 is the next value, right? So it will be reversed, 0. It will start storing from 0. The value of 256 is 0. 257 is 1. 258 is 2. In this way that will be stored here also. Plus 128. This will be stored as minus 128. Reverse. It will start, if the range is overcome, then it will stored from the starting again. So the next topic is input and output function. What do you mean by input and output function? Because every program must take one input and produce some output. That is the purpose we write the programs, right? So what are the input and output functions are? Scanf is the input function, printf is the output function. So scanf, we will scan, right? We will scan a paper. So we are giving the input. Printf, we are taking printout of a paper, printf. So these are the different format specifiers used for different data types. So to read, for example, scanf. Scanf is the input function. So the syntax we will use is percentile D. What is this percentile D? Percentile D is the format specifier used for integer data type, float data type, percentile F, char data type, percentile C, string. For strings we will use percentile S. We don't have string data type, but we have format specifiers for strings. So for integers, see all the first letters, F, C, S. For int, you can use percentile I or percentile D. So the syntax of scanf function is scanf percentile D, comma, after quotations, comma, and the variable name. For example, if you want to read, or if you want to give the value of variable A, int A, so the type of the variable, data type of the variable is integer, and if you want to give the value through scanf percentile D ampersand A, this is the syntax. And if you want to print the value of A, so same format specifiers you should use, and A. See, for reading a variable, for printing a variable, the only difference is ampersand. So what is this ampersand means? Address of variable A. See, these are the different types of printf functions. See, here we are printing only text. Printf, my name is NRCM, and here the value of variable A is 7, and if you want to print the value of variable, so printf, the value of variable is percentile D because A is integer and the variable name. And scanf function, int A, if you want to read the value, reading means you are giving the input, scanf percentile D ampersand A. If you want to print float value, percentile F. If you want to read character, percentile C. In this way we will use. Next, typecasting. Typecasting. So type means data type, casting means converting. So we are converting from one data type into another data type, like int to float, float to int. So we are converting one data type into another data type is called typecasting. We have different types of typecasting: implicit and explicit. Implicit. So automatically one data type will be converted into another data type is called implicit typecasting. See this example. So we have int x is 30 and float y. So we know int means only integers 30, like this it will store. Float means 30.00, like this it will store. Automatically 6 zeros will be stored. So here y equals to x. We are not giving the value of y, but for y we are assigning x. So in y the value will be stored as 30.000000. 6 zeros will be added, because for int x 30 zeros will be added. Okay, but if you want to do the reverse, like float x equals to 30.00, int y, and into integer we are assigning float. So in float we have zeros, right, extra zeros, but in int it will store only decimals after points after decimal point. The digits after decimal points will be discarded, right? In this time we need to do explicit typecasting. How to do means, so destination data type equals to target data type of variable. So in this what we need to do is y equals to, this float should be converted into int. Understood? This float x should be converted as int, and that int value will be stored into y variable. This is known as typecasting. Next topic is operators. We have three types of operators in C: unary, binary, ternary. Unary. The operator works with single operand, A, like A plus, B plus, like that. The operator works with two operands, like A plus B, A minus B. Two operands are there. And the operator works with three operands is called ternary operator. This is very important operator, which is also called as conditional operator. So unary, binary, ternary. So based upon these types of operators, we have 8 different types of operators. Those are, Lara commented on BCCI. So you need to remember Lara, BCCI. Lara, logical, assignment, relational, arithmetic, bitwise, conditional, comma, increment or decrement. So let's discuss about first logical operators. So we have logical and, logical or, logical not. Three operators under logical operators. What is this and, or, not? So we know and. In English language, and means both. I'll do breakfast and I'll go to school. So both will be done. Both will be true. Both will be done. So and means if both are true, then the output will be true, otherwise it will be false. Or, so let's connect this this with an English language. I'll do homework or I'll play. In both the things, only one thing will be done. So in the same way, either of the things, either of the statements, if only one is true, then the output will be true. Only if, see for example, both are true, the output will be true. Both are false, then only the output will be false. In OR, if any one of the statement is true, the output will be true, otherwise the statement will be false. In AND, if both the statements are true, then only the output will be true. If any one of them is false, the output will be false. And NOT, reverse of that. For example, true will be assigned as false, false will be assigned as true. So what is logical AND? So where we use logical AND? So logical operators are used in between two statements. For example, A greater than B and A greater than C. For example, A 5, B 4, C 1. These are the values we have. So first statement, A greater than B, 5 is greater than 4, yes true, and 5 is greater than 1, yes true. If both the statements, if both these statements are true, then only the output will be true. Then only this if condition will be executed. So the largest of these three numbers is A. You can connect with the program, largest of three numbers. If one number is greater than other than two numbers, so other two numbers means both should be true. That's why we use logical AND operator. For example, let us take one example. Age is greater than 18 and you should belong to Hyderabad. Then only you will be eligible to vote. So age should be greater than 18. Both conditions should be true. And location equals to Hyderabad. So if both the conditions are true, then only you will be eligible to vote. In these conditions, in these kind of situations, both must be true, or more than two must be true, all must be true. Then we will use logical AND operator. Logical OR operator. Logical OR means anyone can be true. If you want to connect with real time, so if A is greater than B or A is greater than C, then it will lead to A might be greatest. Might be. Underline the word might be. If A is greater than B or A is greater than C, A might be greatest. So in that particular situation, you can use OR. If any one of the conditions must be true or can be true, then you can use logical OR. And logical NOT. NOT of A greater than B means if A is less than B, then only we will enter into the condition. Okay, this is about logical operators. Next, assignment operators. So assign, we are assigning something. For example, A equals to 5. Equals to is the assignment operator. We are assigning the value 5 to variable A. In this way, we have different types of assignment operators. A plus equals to 5, that means A equals to A plus 5. B minus equals to 3, that means B equals to B minus 3. C D E, like this. This means C equals to C into 2, D equals to D modulus 3, E equals to E by 2. These are the different types of assignment operators. Okay. Next, relational operators. Relational. In generally between persons, how can we define the relation? Either brother, sister, like that, right? So, but in numbers, 2, 3, 5, how can we define the relation? 2, 3, how can we define the relation? 2 is less than 3. So, the relational operators are less than, greater than, less than or equals to, greater than or equals to, equals to. For equals to, we will use both double equals to and not equals to. These are the different types of relational operators. So A is less than B means 2 is less than 3. 2 is not equals to 3. 4 equals to 4. So these are the different types of relational operators. So for example, if age is less than or equals to 18, so this is the relational operator. Then printf not eligible to vote. You can write like this now. So the relational operators will be used in conditions mostly. Conditions, to check the condition, we will use these relational operators. And for example, if age is less than 18 or say greater than 18 and location equals to Hyderabad, single quote, the characters will be enclosed in single quote, string will be enclosed in double quotes. See here, this is a logical operator, this is the relational operators. The relational operators and logical operators are used in combination in if conditions. Okay, this is about relational operators. Next, arithmetic operators. This is very familiar to you. A plus B, 2 plus 3, 3 minus 2, minus, plus, minus, multiplication, modular division, division. 3 into 2. What is the difference between modulo division and division? See, 6 by 2. The answer is 3. 2 3s 6. 3 quotient. The division operator gives the result as quotient. So modulo division means remainder. See, 0. 6 modulus 2, 0. So in programming language we will use most of the times modulus operator. See, like if you want to know the number is even or odd, so how could you say the number is even? If it is divisible by 2. Divisible means remainder must be 0. Divisible means remainder must be 0. In this n modulus 2, if n modulus 2 equals to 0, then number is even. Okay, very important, the difference between equals to and double equals to. Which type of operator it is? Assignment. This is relational. This will be used to assign, for example, A equals to 2, B equals to 5, but this will be used A equals to 2 or not. If A equals to 2, do this, else do this, like that. Okay, these are the arithmetic operators. Next, bitwise operators. Bitwise and, or, not, left shift, right shift. These are the different bitwise operators. Bitwise. So and, we have seen and in logical also, right? Here also and. Bitwise are. So then what is the difference between logical and bitwise and means? In the name itself it is saying bitwise. So the number should be, any number should be converted into bits. For example, A and B. A equals to 5, B equals to 6. You should know how to convert the values, decimal values, integer values into bits. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Simply remember 8421 code. So for 0, all zeros. For 1, under 1, so under 1 you can keep 1, remaining zeros. For 2, under 2 you can place 1. For 3 is not there, right? So how can we, 2 plus 1, 3, right? So for 2 and 1 we will be keeping 1s and remaining 0. For 4 is there. 5, 4 plus 1, 5, 1, 1. For 6, 4 plus 2, 1, 1, 0. For 7, 4 plus 2 plus 1. For 8, 1, 0, 0. Like this we need to convert integer values into bits. So if you want to convert more than 15, next 16, next 32, this, like this it will be doubled. So A and B. A is, the value of A is 101, B 6, right? 110. AND operator. So what is AND? If both bits are 1, same as logical AND. If both bits are 1, then the output will be 1, otherwise 0. So 1 0 0 0 1 0. Both bits are true, 1. 1 0 0 1 0 0. The value of 1 0 0 is 4. The result is 4. So 5 and 6, the result is 4. Okay. In the same way, 5 or 6. R means if any one of the bits is true, then the output will be true. So 1 0 1 5 1 1 0 6. Or operator 1 0 1 1 0 1 1 1 1. Any of the bits is true. True means 1, false means 0. The output will be true. 1 1 value 7. So the value of 5 or 6 is 7. So in this way we have bitwise operators. Here negation. Negation means the, for example, 5, negation 5 is not minus 5. So because, see here, if we have positive numbers 1 2 3 4 and so on, 0 is also there, right? Minus 1 minus 2 minus 3 and so on. See, for 0 the negation is minus 1. For 1 the negation is minus 2. For 2 the negation is minus 3. So for n the negation is minus of n plus 1. So the negation of 5 is minus 6. One number will be added because in positive value 0 is there, right? That's why. And left shift and right shift, very very important. left shift. Let us consider A left shift by 2. The value of A is 5. 5 left shift by 2. So 5, the value of 5 is 1 0 1, right? Left shift by 2 digits, so we need to shift these 2 bits to the left, so means adding 2 zeros at the end. See here, 8421 code is there, right? 5 means 1 0 1. 2 bits move to the left, so the result is 1 0 1. 2 bits will be added, right? Do you understand? This entire thing will be moved 2 positions to the left. So in left we will have values, right? 8 16 32. So this is the final thing, and at the left and the right, at the right it will be empty, right? We will add 2 zeros. So what is the value of this one? 16 plus 4, 20. So 5 left shift by 2 is 20. Do you understand? So means left shift means just add the values, add the number of digits, number of zeros at the right. Next, right shift. Let us understand 8421 with 101. 101, 5 right shift by 2. 2 positions should be moved to the right. So here no place, right? They will fall down. 2 bits will fall down. So under this will be converted into 1. See, 101 will be moved 2 positions to the right. So these 2 bits will be fall down, and the last 1 bit will be at the end. So the result of 5 right shift by 2 is 1. Okay, simply left shift means adding number of zeros, right shift means deleting number of zeros. That's it. Next, comma operator. This is very simple. A comma B comma C. This is the comma operator. To separate 2 variables or anything, we will use comma operator. Next, conditional operator. This is also called as ternary operator. The syntax of ternary operator is question mark colon. So ternary operator, single operand. This is entire thing is one operand only, like plus one operand, right? This entire thing will be one operand. Single operand, 3 operators. Where will be the 3 operators means single operator, 3 operands, A, B, C. A question mark, B colon, C. This is the syntax of ternary operator. So it is used alternative for if else. If else, it is the alternative for if else. See, let's take an example. Let the number is even or odd. To write a program, let the number is even or odd. What we usually write, if A modulus 2 equals to 0, it is even, else odd. We will write this, right? Printf. So the same thing we will write using ternary operator. So first let's discuss about what is ternary operator. A means condition, question mark. If this condition is true, B will be executed, colon. If this condition is false, C will be executed. So before question mark we will write the conditional statement, and if the condition is true it will execute B, if the condition is false it will execute C. So let's try this program with this. So condition, what is the condition? A modulus 2 equals to 0. See, double equals to. It is not single equals to. We are not assigning. We are checking whether A modulus 2 is 0 or not. Condition, question mark. What is B? It is a true statement. If this condition is true, what you need to execute? Printf even colon. If the condition is false, you need to print odd. Printf odd. This is the single line using conditional operator for if else. This is the conditional operator or ternary operator. And the last one is increment or decrement operators. So this comes under unary operators. Unary, single operand and single operator. A plus plus B. These are the unary operators. We have increment and decrement operators under unary operators. Increment plus, decrement minus. Increment means plus means increase by 1, decrease by 1. Decrement means. So under increment we have two types, pre-increment and post-increment. And a decrement also we have pre-decrement and post-decrement. For example, A equals to 5, B equals to plus A. Okay. So pre-decrement, in the name itself it is saying pre-decrement, pre-increment, post-increment. These are the different nominations we will use for pre-increment and post-increment. Plus A, pre-increment, A plus post-increment. So first it decreases the value, then assign. First is it assigns the value, then decreases. Okay. Let us understand with the example. So in both the cases, if A equals to 5 and if you do plus A or A plus, both result in A value 6. See here, what is the difference between A plus 1, A plus? A plus 1 means increasing the value by 1. A plus is also same. Then what is the difference? If A equals to 5, so C equals to A plus 1. What will be the result of C? 6. What will be the result of A? What is the value of A? 5 only. Value of A is 5. The value of 6 is 6 in this case. But in this case, C equals to A plus. Here, after increasing, the value of A will be 6. Okay. A plus means self increment, increasing the value by 1 to itself. In this case, the final value of A will be 5 only. In this case, the value will be updating. That is the difference between plus 1 and plus. So let's come to this situation. A equals to 5, B equals to plus A. What are the values of B and A in this case? Here also we will do the same. A equals to 5, B equals to A plus. What are the values of B and A? So listen carefully. See here, A equals to 5, B equals to plus A. So pre-increment. So pre-increment means increase the value by 1 and then assign. So first increase a value to the 6, then it will be assigned to b. So in this case b value will be 6, a value is already we know 6. Okay, understood? So come this case, first assign post increment, assign then increment, assign. A value will be assigned. What is the a value? 5. And increment. So a value will be 6. See, in both the cases a will be the incremented value itself, but the assigned value, either it is pre or post, you should know. Pre means first increase then assign. The increased value will be assigned. In post, first assigned then increase. The initial value will be assigned, then it will be increased. In the same way, pre-decrement and post-decrement. Minus minus a minus minus. For example, a equals to 5, and in this case b equals to minus minus a, b equals to a minus minus. So a equals to 5, right? First decrease, so 4, then assign. 4 will be assigned to b and the value of a is 4. In this case a equals to 5. In this case first assign, the value of b is 5, then decrease, a will be 4. Okay. Next, expression evaluation. See, expression, what do you mean by expression is combination of operands and operators. See here, 2, 3, 2, 3, these are all operands, plus minus into, these are all the operators. So it is a combination of operands and operators. Here more than one operator we are seeing, plus minus star. So let's evaluate this. 2 plus 3, 5 minus 2 into 3. 5 minus 2, 3. 3 into 3, 9. In one case I got the output as 9. I'll do in another case. First 2 into 3 I'll do 6. 2 plus 3 minus 6. 2 plus 3, 5. 5 minus 6, minus 1. See, for the same expression I am getting different results, right? So which one is correct? So to avoid this ambiguity, we have precedence. Precedence means which operator must be evaluated first, either plus or minus or star. This is called precedence. So we have Bodmer's rule, brackets of division, multiplication, addition, subtraction. So in this case, first division, multiplication, addition, subtraction. So division is not there. Multiplication we should evaluate first. So 2 into 3 must be evaluated first. So 2 plus 3 minus 6. Okay, next addition. 2 plus 3, 5 minus 6. Next subtraction, minus. This one is the correct answer. So in this way we will avoid the ambiguity by using the precedence rule. And next, associativity. See, we have, see here, the operator braces have the highest precedence. Next, unary operators. Just now we have discussed pre-increment, post-increment, right? And size of operator. Size of operator gives the size of the particular data type. For example, size of int, that is 4 bytes. 4 will be the answer. So next, after braces, we will be having unary operators as highest precedence. Next, multiplication, modulo, division. These are all having same precedence. Next, plus minus. Next, in this way, all the operators will be having precedence from higher to lower precedence. You can follow this chart. Okay. In the above example, see here, 2 by 6 into 5 plus 7. So here, division, multiplication, both are having same precedence. In the below chart we have seen, see here, multiplication and division both are having same precedence, right? So then which one must be evaluated first? So in this situation, associativity comes into matter. So either left to right or right to left. Associativity means from which side the expression must be evaluated. See this, left to right. So first 2 by 6 will be evaluated, then into 5 will be evaluated. Okay, this is called precedence and associativity. So only for unary operators and ternary operator and assignment operator, for these three operators only we will be having associativity from right to left. For rest of all, left to right. For every expression must be evaluated from left to right, except if you have a unary operator or ternary operator or assignment operator. This is about operators. Thank you.